Hello, my name is Michael. You're welcome to my YouTube channel. In this video, I'll be talking about IPv4 IPv6 network connectivity. This is a series, and this is the part 1 of that series where I'm exploring interaction between infrastructures of IP versions. Here, I will be demonstrating how IP version islands can be made to interact with each other. But before we go deeper, I would like to share the agenda of this video with you. So please sit back and enjoy. Before we start the scenario, there is a quick recap I'd like to share with you. And this will take us through the basic things that we need to know regarding IP communication, the addresses, the format of addresses, the limitation of each of the versions of addresses, as well as the differences and the similarities between the versions of addresses. Thereafter, we will go into the scenario that I've prepared for this video, and that is mainly focusing on interacting with IPv6 only infrastructure using ISATAP. Then I will share a view of the implementation as well as the verifications that we need to do in order to confirm the things that I will show you. We would also combine this with packet analysis using Wireshark so that we can see what the header of each of the packets look like on wire when we do the packet sniffing in order to analyze. So with respect to communication styles, you must have seen or probably heard about at least one of these styles, the unicast, which talks about one-to-one communication on the network. Usually you have one server as well as one user communicating with each other. Now, the server can also be a user, but it all depends on the scenario. In most cases, even when you have two users talking, they can either talk as peers or they can talk in form of client server, depending on the application that you're using, by the way. So unicast talks about one-to-one network communication. In the case of the broadcast, one server communicates to all users on the network. That is what the broadcast is. Then the multicast talks about one server talking to some users on a network. And this simply means not all users would receive that data when the server sends it to a multicast address. It's different in the case of the broadcast. The broadcast on a network segment is expected to apply to all the users on that segment. But in the case of the multicast, they can all be on the network segment, but in specific multicast groups. And only members of a multicast group are able to receive the data sent to that multicast group. Meanwhile, in the case of Anycast, it talks about multiple servers sharing the same IP information in order to easily distribute content or data to different users across different aspects of the network. Now, this particular application, or let's say style of communication, works for content distribution, where the network decides which of these servers would respond to any of the users' requests for either data or content. And the network decides this based on the proximity that it's able to calculate based on its perspective of the location of the server from the perspective of the user's request. So the network decides basically where to go in that scenario. And now, with respect to the address types and the header format, this is what IPv4 header looks like when you check the Wireshark. So it's more like you're seeing these fields on wire, how they appear. On the other hand, this is the documentation that we have from the RFC, which shows how each field is packed into the IPv4 header format. And you'll find out that all of them actually present when you check it indeed. Here are examples of IPv4 addresses that you may come across. You have the unicast, you have the multicast, you also have the broadcast. And now we move to IPv6. Similarly, we have one image from the RFC as well as the one that is from Wireshark. And we can see that there is not much difference between how they appear in each of the cases. You have the source address, you have destination address, you have the version, you have other fields also. And when you compare these two images, you find out they have the same information of the field that has been indicated. And similarly, we have different types of addresses for IPv6. And here there is a slight difference because there is a different type of unicast address in IPv6. We have the link local unicast address, which is only limited to the local segment. That is, any interface that you enable IPv6 on automatically gets this address type. It's used to, detect the neighbors on a segment that are directly connected. And we also have another type of address, which is called the unique local address. This is previously also referred to as the site local, because you can use this address mainly within a site, within a private site. It's different from the link local because this is limited to just the directly connected segment. But here, this can be used across a site, but you can use this for internet communication because you need to perform NAT in order to get it done, basically, or other technique that you might want to consider for that purpose. And that takes us to the global unicast address. This is the type of address that you can use directly to communicate with the internet without considering the NAT in that regard. And usually registry assigned or provider assigned, which means you have to go to an authority that has sole ownership of that address in order to be able to use it before you can make use of it on the internet. And lastly, we have the multicast address, which simply means that you have a similar technology as you have it in the IPv4, where multicast is used for communication to a specific group, not in the case of broadcast. And mind you, IPv6 does not support broadcast. So you won't find anything broadcast in IPv6 context. However, it uses the multicast in a way that is similar to how IPv4 uses the broadcast, but they are not exactly the same. So I need you to take note of that very importantly. You might ask, what about the anycast address? Yes, the anycast address is usually a kind of unicast address. However, it is the unicast address that is replicated across multiple servers that have the same content to distribute or to share, which is why there is no specific group of addresses that are termed anycast. Yeah, but the usage of the addresses is what makes it anycast, just as I've described in that scenario. So let's move on to the limitations. Here we talk about the limitation of IPv4 and IPv6. It doesn't really mean that we are saying one is better than the other. At least that's not what I'm driving towards. I'm driving towards the knowledge of why IPv4 can be used up to a certain extent and why IPv6 should be considered from a certain extent. And in certain cases, you will still find the pros and cons that applies in both cases. So this is not a comparison. This is only for knowledge-based cases. And here we have the differences between the versions of IP. One obvious difference there is that IPv4 has lower address spaces or length compared to IPv6. The other thing there you will find is that IPv4 has lower overhead compared to IPv6. Of course, when you have 128 bits of addresses, you have to plan a lot well than you would be doing when you do the planning on IPv4. These are the very common ones. There are many other differences that you would find across different documentation as well as use cases. Yeah, but these are the ones that I wanted to share with you. This takes us to the similarities as well. You must have seen it before that there are certain things that are common in both cases. Example would be the usage of the IPv4 and IPv6. They are mainly for packet transport and delivery, and you can't take this from them. They are very efficient when it comes to packet transport and the delivery. And similarly, you have version in their header, you have source and destination address field, and so some other similarities that you'll find. And of course, you'll find it to be useful in unicast, multicast, and anycast communication styles. And of course, the rest of the highlighted information in the table. Now, this is the scenario. Here we have two islands of IP versions. On this side is where I'm speaking from. That's my home network. And on this side is my lab, which is running IPv6. In most cases, you would find this in different environments. One organization, two infrastructure islands. You also, in many cases, would see this inspired by different forms or triggers for transition, which may be acquisition or even merger. So these are things that you will definitely find in reality. Now, back to this. Here is my lab environment where I have a 6 router infrastructure running IPv6 OSPF version 3 precisely, and I have multiple servers, but there is one specific that will be used for this video. And some of the things that we want to see includes the interaction of my home network running IPv4 only to the server that is running IPv6 only. Based on that, we will see how this is done. But before then, there are certain things we have to do, which is to ensure that the connectivity to the virtual lab gateway from my PC, that is the IPv4 user, is established. That is, I'm going to check to see that I can reach this node. The next thing is to ensure that the virtual lab gateway node is able to reach the server on the indicated IP. That is, I am going to check if I have a converged lab network on the IPv6 case. And that's what the second point is saying. And the last, which is the key for this interaction to happen, is to establish the ISATAP tunnel from the IPv4 user to the virtual lab gateway. That is, this tunnel will then be established in order for us to see when we establish this tunnel between this user, this me, and this gateway, would I be able to reach this server using any form of services that it is running on IPv6. And that's where we're going now. I will then open up my terminal in order to get to the servers. I'm going to mention that the management method for each of the systems that you see or each of the routers is by IPv4, which is to make it easier for me to, access them. So it's not used for data in any way. I will then start from the virtual lab gateway. So we'll quickly check OSPF neighbor adjacency. You can see that we have the virtual lab gateway, which is actually 2. That's router 3 and router 5. If we go to the router 2, which is in this case the net 172 gateway, we will find the neighbor adjacency as well to be 2 as well, which are router 4 and 5. And if we keep going to the other ones, you can see router 3 has 3 peers or 3 neighbors, which includes router 4, router 1, and the core. The core switch there is the DR, the designated router in that scenario. which is holding the backbone area. Of course, we have router 4, which has the 3 peers, including the core, acting as the designated router, as well as the router 2 and router 3. Then here we have router 5, which is also with 3 peers, including the core, acting as the DR, and the same applies to router 5 in that case. Here we have a core switch, which is with 3 peers again, and those are the backup designated routers as we have them. And just to also show you that we have a converged network, here is the database which you will find. And mind you, I'm not doing any form of summarization yet, so it's not the purpose for which this video was recorded, so I'm not going to spend much time there. We can deal with this in another video where I will break down OSPF version 3 from the very complex nature of it to a very simple part that makes it easier to understand. And here are the routes. We can see the inter-area route. We can see the external route as well. And in some cases of some other routers, we will see the intra-area route. Like in this case, we see the intra-area route, the inter-area route, as well as the external route. So that's one good thing, that we have a converged network. And the next would be for us to test the reachability. So here I have to quickly check first if we have this route. That's 2026 1147. And of course we have a route there, which is landed by OSPF. Now we can test up to .1, and we can check .2 as well. So we can see that the first 2 requirements here, or the first 2 steps, have been established. Notice we have completed this part and we have completed this part. Okay, no, this I have to complete now, which is on IPv4. Can I reach this? Of course we have, definitely. That's why I'm able to reach it in the first place, so that's fine. And now we will check out what we need to do to establish this tunnel. And to establish the tunnel, you only need something, and that is to configure the tunnel. I've used tunnel 0 on this gateway because it's facing this direction. What I mean is the tunnel is on this gateway facing this direction. And since my PC is already able to reach this through my home network, by the way, I have another set of devices here. I can't go deep down into that, but just for you to know, it's interfacing with that gateway from a MikroTik device. And here you will find out that I have routes that are coming from different perspectives, and this is the one of interest to me at the moment, which is the lab environment. So we go back now to this point, and I want to show you what you only need to do on the gateway, which is to configure a tunnel. It doesn't have IPv4 address at all. It only has IPv6. And if you would check that, you would also find out that it has a link local address that has been assigned to it, which is here, as well as the multicast address which it uses. This is normal IPv6 behavior, but I can go deeper into that in a different video. What we're saying is, once we verify that we already have a tunnel configured to terminate ISATAP sessions. We can go now to check the ISATAP adapter on my PC. Here we can see that it's still disconnected, and now I have to open one as an admin, which is I'm opening a new terminal as an admin, and here we can configure the ISATAP interface. We ensure that we get the connectivity established, and here we have this IPv6 ISATAP. First we can show state. See, it's enabled, and now we can show router. We know that is configured, but why is it not established? That's because in some cases we have to do it again. And then first I will disable the state and re-enable it. Then we can check at this level if there's any difference. There is definitely a difference because now the ISATAP is no longer at the bottom. We can find it somewhere here exactly. So we can see now that it has acquired an IP, which is, of course, if you check my previous video on ISATAP, you will find why we have this, and this is recognition for ISATAP addresses. You would also find out that it automatically generated a link local, which is ISATAP based, and that is coming from the interface of the tunnel, which we have here. And you would see that actually matches what we have in the case of the ISATAP. And now we can check what we have in terms of reachability to the server address. So our server address when we checked was this, which is the 2 of that address. We can go first to the 1, which is the gateway, and that simply means we are going through this gateway to get to this gateway. That is the 1. Now we'll target 2 as well to be sure that we are fine indeed. And then we go to 2. And you can see now that we are able to reach. Let me put this on this side. Exactly. So what we are saying is from my PC right now, I'm able to reach this server, which is through this gateway. Let me shrink this a little bit further. Exactly. So now to be sure that indeed we are hitting the right server through the right path, we can run the trace route as well, which takes us through 11, which is this, takes us through .5, which is the lower path, takes us through .2, which is this, and then it gets to the server itself. So this is exactly what we intend to do, and that's why I would say that this implementation has been successful. We just need to do some verifications now, and I will take you now to this phase to verify. First, we did the first verification on this level, which is seeing that the interface on the PC is established for ISATAP connectivity, and that's this number 1 level. Another thing we could do is to check the commands that we did before. Okay, it's here, which is to check again what it looks like. We have a router which is configured. We also have a state which is enabled. So this is also another level to which you can, verify if what you have done is actually intact. Then the next phase is here on the gateway, which is to check the neighbor table. And here you would find that there are certain neighbors that were learnt over the tunnel. which simply means the tunnel is established with another remote location, in this case my PC. If you do not find this, that means the tunnel is likely not established yet. The other thing is the trace route that I ran on this side, the pings as well as the trace route, and you can see already that things are established generally. For more details on ISATAP concentration, check the previous video that I have released on ISATAP, and this would give you more insight on some of these verifications that I mentioned. Now, let's go to Wireshark and see exactly what we want to find. And first, I will open up the Wireshark on my PC so that we can check what is going on. So I'm running this on my wireless connection, which is here. And you would find out when we go back again to check IPv6. So this definitely tells you this is ISATAP connection. And let's go now to target the destination that we wanted to target. So I'm going to rerun my pings here again, and we can see our ping is replying to us as well. The ping request and reply. That's the target server. Of course, we want to do something with SSH, so I'm going to do root 2026 1147 124.2.2, and here it's already asking for the key. Then we can see that the server actually is responsive. You can also see the communication here, which already shows us that we are targeting the server on SSH. This is also applicable to other applications that support IPv6 basically. And you can see also here what we have in the case of the type of address is global. Of course, this is a lab environment, so it's just to make it a little bit, interesting to see how things work basically. So you can use the site local address as well in your case for practice, and things will work still as long as you're not trying to route it through the internet basically. So that is fine. And that is what you find also in case you decide to do the inspection on the other parts which we have here. Currently, this is what we have as the inspection point. If we decide to inspect at the server, you will find a matching packet types, and the trace logs as well will match definitely. And you can also inspect around the gateway as well, which is going to be similar to what you have here. And this leads us to the conclusion here. You have seen that having two islands or multiple islands does not prohibit you from interacting between them. It all depends on the use case and the business requirements that will drive that consideration to make it happen. In the next video, I will show you another solution that is different from ISATAP. Thank you and enjoy.